Let's look at example 8 together. We're going to use our properties, the ones that we just talked about, in letters E and F. In example 8, they want us to take 6 to the 2/3 power times 6 to the 1/3 power. So since we have same base exponents going on here, and we're multiplying them separately, we're not taking an exponent to another exponent, we can use our first property. So this is the same thing as 6 to the 2/3 plus 1/3. Same base as 6. We can add both of our exponents together since we're multiplying. So this gives us 6, and since they have the same denominator, we're adding our fractions together. We get 2 plus 1, which is 3 over 3. We know 3 over 3 to be the same thing as 6 to the first power, so our answer is 6 for letter E. In letter F, we have 3 to the 3/4 power being raised to the 4th power. So the whole value, the whole term, is being raised to the 4th power. So in this case, we're going to be using our second property listed above, the one right here, and we're going to multiply our exponents together. So we have 3 as our same base. Since we're multiplying exponents, I can make the outside exponent as a fraction by putting it over 1. 3 times 4 is 12. 4 times 1 is 4. 12 divided by 4 is 3, and 3 cubed is 27. And that's our answer for letter F. Letter G on the back side, we're going to be using the same properties that we did, or that we have on the other side. We have 16 times 25 all raised to the 1/2 power. So we could potentially multiply these two together, but since I know that the 1/2 power is the same thing as square root, 16 and 25 are both perfect squares. So I can easily distribute the 1/2 to both of the inside terms and make it a little bit easier for myself. So this is the same thing as 16 to the 1/2 power times 25 to the 1/2 power. Square root of 16 is 4, square root of 25 is 5, so 4 times 5 gives me 20. If I did it the other way and I took 16 times 25, I would get 400 if I did it this other way to the 1/2 power, and I would have to take the square root of 400, which is also 20. So I get the same answer either way that I look at it. However, if you don't have a calculator, it's a lot easier to distribute that 1/2. Getting fuzzies all over this paper. Easy to distribute the 1/2 first and then multiply after, since you're dealing with smaller numbers. In letter H, I have 8 to the negative 1/3 power, and if you remember that negative for our exponent means I have to flip it in either the numerator or denominator. So since this whole value can be placed over 1, I can rewrite this guy to be 1 over 8 to the 1/3 power. 8 to the 1/3 power is the same thing as the square root, or the cube root of 8, and we all know the cube root of 8 is 2. So I get 1/2 for my answer in letter H. In letter I have 7 to the 5/2 power divided by 7 to the 1/2 power. Since I have same base exponents going on here, I'm dividing so I can subtract my numerator exponent minus my denominator exponent. 5/2 minus 1/2 is the same thing as 4/2. 4 divided by 2 is the same thing as 2. 4 squared we know is 49. So letter I is 49. Moving on to like radicals. Like radicals, or two radicals are like radicals if they have the same index and the same radicand. So I'm going to give you 3 examples here, and we're going to pick the 2 that are considered like radicals. Let's look at the cube root of 3, 4, cube root of 2, and 4, cube root of 3. Out of these 3 radicals, 2 of them are like. And the 2 that are like are the ones that have the same index and the same radicand. So if you look closely, all three of them have the same index, but only two of them have the same radicand. And remember, radicand is the inside number of your radical symbol. So the two that are alike are the cube root of 3 and 4 cube root of 3. And when you have like radicals, you can add and subtract them using the distributive property. So we're going to look at example 9 to see how this works. In example 9, you have letter J and letter K. Okay, so if we look at this, in letter J we have 4 fifth root of 3 plus the fifth root of 3. Okay, so in this case, I just want to point out, if I had something like 4x plus 1x, because my variables are the same, I can add these two together to give me 5x as my answer. Same thing works down here. If I have like radicals, I can treat them similar to how I treat my variables when I have like variables, or similar variables. So in this case, I have 4 fifth root of 3 plus 1. I can have that 1 that's kind of invisible in front of my x. I can put that 1 invisibly in front of my radical if I don't have a value out in front. Fifth root of 3. Since the fifth root of 3, both of them are like radicals, my index match up and my radicands match up. I can add my two outside numbers together, and my radicand just gets tagged on at the very end, just like x does up above. So my answer for letter J is 5 fifth root of 3. Same thing in letter K. In this case, I'm not looking at radicals, but I'm looking at my exponents, just like my previous videos. We shared the fact that radicals and your exponents can be the same thing. They can mean the same thing. They're just in two different formats. So in this case, since I have 11 to the 1/3 power, 11 to the 1/3 power, I can treat them just like if it was 7x minus 10x, because these two are exactly the same. I have the same base and the same power with the same numbers in my numerators and in my denominators. So 7 minus 10 gives me -3, and since these two are the same, I get 11 to the 1/3 power as my final answer. I want you guys to take a moment and work on numbers 23 through 27. The Now You Tries, and we'll meet back in the next video, our last video, to talk about example 10 and 11.